Video help for problem 10.8. For part A, let's just rewrite equation 10.42. This will be the same equation in both editions. We have our signal. Remember, we used to have our signal in just k-space, but now we've got an additional sum. We're summing over all space, all the protons everywhere, but now we're also distinguishing them because protons could be in different molecules and different tissue. It could be in water, it could be in fat. And so we change the sum over all those molecules to a integral over this. Remember what sigma is, it's just the factor representing the shift, the tiny shift in the magnetic field due to the shielding in a molecule. And so it's just some fraction defined with a minus sign, so it changes this minus to a plus, times a fraction of the original B0 precession frequency. I've written this in terms of T prime. T prime, remember, is when we take and we're looking at our maximum signal at echoes. T prime is defined to be 0 right at the echo, right at the echo that we see. Now, what I wanted to say is that, if we somehow got all of the kx and ky data for any value of t prime, then we can actually look at, for example, t prime equals 0. If we look at t prime equals 0, this is just kind of an average then over all the different molecules. And that does give you then an average of an average image. Now, if you go to figure 10.22, this is really helpful. If you look at that, you will see that for every pixel in kx and ky space, we've got some kind of a evolving signal due to due to the spread and chemical shift. And so at t prime equals 0, by the way, that's at a maximum. If you go and look at this picture here, you'll see these signals, that are maximized at t prime equals 0, but changing because of the kx and ky changes, or kx, ky data. Well, that'll help us for part B. To say part B in a different way, you know something. You know that a Fourier transform, suppose I have some, frequency function, and I want to find out, what the Fourier transform of this and therefore in time would be. You know that if t equals 0, this is just an average over h of f. If t is not 0, imagine t is, growing positive, more and more positive as t goes large. What in general happens to a Fourier transform when t gets large? Think of any example. Look at any example. What happens to it?